Hello and welcome to today's Into Infinity live broadcast every week. Every week, a new topic. And today it's going to be about solar geometry. Right. Last week I talked about the atom and what geometries are found in the atom. You can still find the recording of that on YouTube. And today I'd like to talk about the solar system, so the sky. So let's shoot right over to the presentation. Loading. Right. Okay. Obviously, the lens of geometry. And the sky has always been a mystery in ancient cultures. Are there actually patterns, or is there a divine plan? These are the big questions. And we're just going to see today if that's actually the case. So there's a guy called Johannes Kepler, and he said, where there's matter, there is geometry. And so far, it seems like to be true, as we saw last week when we looked at the atom. That actually all matter, just kind of adjusts itself towards these certain symmetries, just like our body has a certain symmetry, just as we see flowers and certain symmetries. Symmetries, geometries, patterns, they're everywhere. We actually even think in patterns. So let's see what Johannes Kepler, who he is. He's a German astronomer, mathematician, astrologer. He's actually one of the key figures of the 17th century scientific revolution. I mean, he did so many things. He's most famous for his laws on planetary motion, which actually then built the foundation for Newton's theory of universal gravitation. However, we're not going to go too much into that. But what's quite amazing about him, I mean, he was quite, he was interested in a lot of different things. And one of his skills was actually astrology, right? So reading the stars and the star signs. And he actually also studied theology. So he was a big believer in God and the religions. But at the same time, he was a very bright man. So he was doing mathematics and also looking at the stars. And really having that holistic view, I guess, gave him a lot of new inspirations. And one of those inspirations I want to talk about. And it's concerning the solar system. So for a very long time, it was thought that obviously the stars that they are orbiting around the Earth. So actually that the Earth was the center of the universe, and in terms of religions that made a lot of sense, that we are actually the center of creation. However, there's a lot of people that suggested it's not like that, that actually we're not at the center, that the sun is the center of the solar system, and that there was this heliocentric model that was suggested that actually the planets are moving around the sun. And Kepler was actually one of the first people who defended this heliocentric model and suggested that actually all the planets are moving around the sun. And that's a really important point when it comes to some of his work. And his very first work he was working on was the Mysterium Cosmographicum. And in this work, it was really amazing because he was just, I think it was kind of like an awakening scene or enlightening thought he had when he was teaching, about the stars. I think it was about Uranus and Jupiter. I'm not quite sure about that, but about the stars. And then he was thinking about the stars in the arrangement, and he realized that they're actually following geometric principles. So he was like, oh my God, maybe there is this divine plan by God, because obviously he was a big believer that there has to be some sort of universal pattern, a unified theory of everything. And that actually everything has a certain reason, everything has a place because of a certain pattern, a certain plan. And so he wrote this book, and he said that actually the planets, because he thought at the time there were only 6 planets known, and he thought that he could fit the 6 planets into 6 spheres, And the 6 spheres are arranged in such a way through geometric principles. First, he was thinking in 2D, but then he said it doesn't quite work in 2D, but then he was working with 3D. And as you may know about the 5 Platonic solids, these are the most fundamental 3D forms, which are the ones you see right here, and I talk about them a lot. But yeah, these are the only forms that can fit in the sphere in 3D and are completely in harmony. They're completely regular. That's why I also call it regular polyhedra. And yeah, and every point of each solid is exactly the same distance to the center and to each other. And this is quite unique about these 5 solids because there are no more. You cannot actually not create any more 3D forms that have that characteristic. So, so he said he was playing with these solids, and he's like, okay, if you can nest them inside of each other, and you can actually do that. For example, if you see here, there's the octahedron, which has 8 faces that fit perfectly with the 8 vertices. So vertex is basically the point, the corner of each cube going into the center. So the cube has basically 8 vertices, and the octahedron has 8 faces. So they actually match each other like Russian dolls. And the same you could say for the dodecahedron with 12 faces and the icosahedron with 12 vertices. So they're kind of like, you know, like Russian dolls. They're opposites of each other. You can place them inside, and in this way you can create kind of like yeah, an architecture that is built around these shapes. And each shape again fits in the sphere. So he thought basically that these solids must somehow be involved in the spacing of the planets. And he thought because, yeah, with the sphere is 6, we have 6 planets, it might explain why only there are so many planets. The tetrahedron, on the one hand, I just want to mention it here, it's actually a, we call these duals, yeah, when they fit inside of each other. The tetrahedron is a dual of itself. But obviously it also plays a role. So when he was looking at these, it's like, okay, how do they fit together? And here we see it. This is like, yeah, the duals, they can fit inside of each other. So the octahedron fits inside the cube, or the cube can fit inside the octahedron. So you can just nest them into infinity inside of each other and shrinking in size, scaling smaller and smaller, or bigger and bigger. And that's the beauty of geometry, you know. It doesn't matter what size it is. What matters is that it's all a relationship to each other. So obviously I can blow up this cube to the size of the solar system and then just see how the sphere of the cube, which is outside, compared to the sphere inside of the octahedron, if that actually matches maybe distances of the planet. And it turns out, and this is his model from the Mysterium Cosmographicum, where he was playing with the solids, and I'm not saying that this is actually 100% correct, but it's been very close. Let's say in modern science, this was actually abolished, this idea, because he was, yeah, the worst was 5% off, because obviously later on he came up with the laws, the 3 laws of planetary, the laws of the planets, yeah, the orbits, that basically that the planets don't move in circles, but they move in ellipses. And some other laws that are built on that, which then built the foundation for, yeah, for Newton and stuff like that, and Einstein. But nevertheless, he never actually abolished the idea of this geometric model, because, yeah, it's very, very closely related to that. And he said that basically you could say, yeah, these orbits might have a thickness. So the ellipses, they are still limited to a certain circle. So an inside circle and an outside circle. And if you take the average, it's actually fitting. So he thought that, oh wow, he discovered some sort of divine plan. And there was another book he wrote, which is Harmonices Mundi, which is also built on a very ancient saying or belief. And here I'm just going to read out Pythagoras. His quote, he said, "There is geometry in the humming of the strings, there is music in the spacing of the spheres." So what does it mean? The spacing of the spheres means that actually in the geometry of the spacing, you find actually the laws of music as well. And this idea of music, which is one of the foundations of the quadrivium, you know, from ancient Greece, where, you know, this was the foundation of science. They're looking at numbers in space, geometry, numbers in time, music, numbers in space-time, the planets, and pure number, which is mathematics. So music was playing a really, really big role, because they thought that actually the laws of music, you know, the 7 musical notes, the octave, the half tone, all of these laws are fully based on mathematics. And actually that can even also be translated into the planets. Now let's have a look at this cosmic dance. And what's quite interesting, if you're following the planets, yeah, and you look at how do they move in comparison to another planet, you see that at certain rotations, if they reach a certain rotations, it actually makes, yeah, it makes completely geometric mandalas, yeah, as you can see here on the left. And especially, let me just get the pointer, especially when we look at here Mercury and Venus, we even see that it makes a triangle, and this triangle actually even maps the idea of an octave, which is, yeah, 2 to 1, yeah, so basically a doubling factor, which is the octave in a sense, because when I play guitar and I put my hand on the middle of the string, I'm halving the string and I'm creating the next note 1 octave higher. And this in space is actually presented by a triangle, which holds a space inside a circle with another triangle outside, and that relationship is 2 to 1. So actually the orbits, the mean orbits of Mercury and Venus hold actually the musical octave. And this is not it. There's many other planets that show certain relationships, and there's a really, really amazing book, and this picture is out of, which is the Little Book of Coincidences by Wooden Books, which explain really nicely how this works. But as you can see here already, yeah, you have different patterns with different planets to each other, and obviously they're making this beautiful cosmic dance. And so which geometries are behind this? Yeah, and here we've listed them again. And this is right here. You see Mercury is basically the blue circle. And this is the average, remember, it's always the average. And Venus is then the outer one, if the sun is in the center. And if this is the average, it actually maps halving. Yeah, so this circle outside is double the size than the blue circle. And it maps the planets by just a simple triangle and the spacing of circles. And we have other planets like Mercury and Earth. It's mapped through the pentagon. We got Mars and Jupiter, and all of the other planets, which show beautiful, beautiful geometry. And it's quite fascinating that actually, in astronomy and stuff like that, we don't learn this in school because obviously it's not 100% correct. But if you think about geometry, it's true. Nothing ever is 100% correct. Yeah, nothing in reality matches, let's say, the golden ratio 100%. Or it makes a perfect circle. It doesn't exist. It exists though in our theories, in our mind, that we can make these perfections, but reality is somehow a little bit off. So what it means is this still useful, this model? Why not learn it and maybe find a pattern that matches also, in different scales? And you see that the Earth and Jupiter, so this is the sun in the center, the blue circle is the orbit of Earth, and the outer circle is the orbit of Jupiter. And it's basically mapped through this fractal called the Star of David, which is a very, very spiritual symbol, right? And what's amazing about this as well is that this triangle on the outside, yeah, if this is Jupiter here, and I have actually a real map of the solar system here, so this is Jupiter, then actually on the other corners of this triangle, this is the asteroid belt. Yeah, we know that after, we have Mercury, Venus, Earth, Mars. After Mars, we have the asteroid belt. And then after the asteroid belt, we have Jupiter. Now, the asteroid belt actually follows the pattern of a triangle. And that's really amazing. And actually, this triangle somehow makes these, there are places, in science we call them Laplace points, where actually more asteroids just aggregate more. And they don't actually know why exactly this is like that. You just say there's certain distances. But if you think about geometry, it kind of makes sense that actually these asteroids, they call them the Trojans and the Greeks, which is just the aggregation of these asteroids, they follow that triangle. And this is also obviously because also Johannes Kepler was looking at 2D, but he was also looking at 3D. And in 3D, you can actually map the same image to, I think it is 99.5% accuracy with the Platonic solids. And this is again taken from the wooden books, this idea. So you can place an octahedron, a cube inside the octahedron, and another octahedron in a cube. And if you place a sphere in there, that would be Earth. And if you place another sphere around the whole thing, that would be Jupiter. It's the scaling, and you could actually even do it the other way around. So you can use a cube and then the octahedron and then another cube inside, and that would make exactly the same distance. So even in 3D, we have this geometric blueprint that beautifully describes the average orbits to a really highly accurate, but it's not 100%. So obviously in modern science, they don't look at it in this way. And probably also because Johannes Kepler didn't much know about gravity and why the wobble actually also is happening. But what's interesting, the first shape that you can find in the atom, in the electron cloud. So the atom consists out of a core, which is represented right here with a dot in the center. And then these electrons outside, normally you have always this image that it makes these shells, right? But actually that's not quite true. Just the first two shells make a sphere, but after that you have also different geometries, and one of them is the p orbitals. And the p orbitals just show us that the electrons, they are somehow located on one side, while the other pair is located on the other side. And you have basically three of those, which means you have another one on another axis and another pair on another axis. So you have actually three axes with, each two electron pairs opposite. And we would normally describe it just as lines, as geometricians. And what it does, and it actually, you can already tell here, it's actually an octahedral symmetry. So the octahedron, you can find it, how we nest it. We nest the octahedron. Also in the cube, but within a tetrahedron. Then the cube is nested in a dodecahedron, and the dodecahedron is nested in the icosahedron, and everything is in this little nested set. And it turns out that actually the same nested set, you can apply this also to the stars. And we already saw that the octahedron and the cube can actually then match the planets of Jupiter and Earth. So it's quite fascinating that we can find similar patterns above that are also below. Now obviously Johannes Kepler was dismissed by modern science, but if we take going back and just having a look at the geometries, and they may not be perfectly 100% accurate, yet still there is a pattern. There is a pattern that has amazing similarities to the pattern of the atom. And if we're looking at reality more, that there is a pattern that is then also around you, the same pattern that's around you, the same pattern that somehow makes these beautiful symmetries and flowers and all this, the things that we see. Maybe we are much closer to an understanding of what reality is, and if there is maybe, indeed, a divine blueprint, as Johannes Kepler was suggesting, because until the end of his life, he always thought that this geometric model was actually not wrong. He was just adjusting it. He was saying, okay, there are ellipses, but these ellipses are still constrained through certain geometric relationships. And the more we look into this, the more we look at the ratios and the principles that are happening between the planets and their relationships to music and the relationships to atoms and the relationships to space, the more we seem to find out that there is a pattern that stretches from the stars above to the atom below, and also it's within us and without us. And it seems to help us also to find more of a perspective on what we're supposed to do in life and how we can align to this pattern and live more fully in harmony. This was to this live broadcast. I got more broadcasts coming up, obviously, every week. Next week is the last one of the series for this month, which is about fractals, and the infinity of fractals, as you can see here. So next weekend is the last one of this month. From next month, I have decided to move the broadcast. So the broadcast is going to happen then during the week, I think every Tuesday. And the whole month, next month, will be dedicated more to the atom and the atomic geometry. If you enjoyed this, I'm just going to move back here to, back. So if yeah, you enjoyed this, yeah, I'm very looking forward to many more yeah, geometric snippets that I like to give you. I have a couple of workshops coming out next month, which is more concerned with how we can use geometry as well in shifting our perception of ourselves and what kind of space we're living in, how we can also who we are and why we are the way we are, and how we can align ourselves to this, yeah, seemingly holographic universe, this beautiful simulation, and this pattern that just seems to really make such beautiful expressions. And obviously, yeah, the more we align with that, the more we also feel. We feel that this, yeah, seems to be the right kind of way to act and to, yeah, to process information. So if you would like to know more about how to implement geometric knowledge also in your meditations, there's a lot more coming up. We have a few problems with our website right now, so hopefully we get that sorted, and we have a complete new launch of the website with a bunch of new information. Until then, just check out the YouTube channel. We have a lot of recordings over there, and yeah, just stay connected, sign up to the mailing list, and please, if you would like to support us, there is a link next week. Until then, see you.